Greetings and welcome to In-Depth. I'm Dike Rostant. We are discussing the recent weather, tropical cyclones and more with meteorologist Gary Benjamin. Welcome, Mr. Benjamin. Thank you so much for spending the time. I'm wondering if it's rain finished for the month. Is it just the beginning? What is the state of play at this point in time?
Well, we are into the hurricane season and the rainy season, so we can expect rainfall, continued rainfall over the next couple months, at least until November for the hurricane season and until December for the rainy season.
All right, thank you so much for that. There's a term that we're hearing a little more normally. In times past, we'd hear hurricane, hurricane, hurricane. Now we're hearing tropical cyclones. Is there a difference? Is there a distinction? How do you define both of those terms?
Okay, the tropical cyclone is a generic term for a non-frontal, a synoptic scale low pressure system over tropical or subtropical waters. And it has an organized convection and a definite cyclonic surface wind circulation, which is counterclockwise in the northern hemisphere. Now, in our area, in the tropical North Atlantic, we have designated different names for the tropical cyclones. So that in the Caribbean Sea, the Gulf of Mexico, the North Atlantic, and the Eastern and Central North Pacific Ocean, cyclones are designated according to the wind speed strength, such as tropical depression, tropical storm, and hurricane. In other areas, you may hear them calling it cyclone, typhoon, and things like that. But in our area, we have these designations for the tropical cyclone according to the wind strength as it develops.
And I like the fact that you just mentioned the word develop as it develops. What are some of those conditions that would lead to these sort of phenomena developing?
Well, first of all, you have to have a warm sea surface temperature, about 26.5 degrees Celsius. There must be atmospheric instability, either caused by surface heating or surface convergence or some kind of disturbance. You need to have a deep layer of moist air, high humidity in the lower and middle levels of the troposphere. That is for easier vertical connectivity and convectivity. If you have dry air, it would lead to evaporation and cooling. So the pressure would get high and we would have no development. So with the moist air, it facilitates the development. We also need enough Coriolis force to sustain a spin around the low pressure center. And the Coriolis force would get that type of strength, so to speak, when you reach about 6 to 8 degrees north latitude of the equator in the northern hemisphere. You also need to have a pre-existing low-level disturbance, as I said, a focus of something happening there. That is thunderstorms forming in a relatively small area and becoming more and more congested with convective activity. Also, we need small, low vertical wind shear as you go up. We don't want to have the wind at different speeds and direction, sort of breaking it apart. And also we need an upper tropospheric anticyclonic outflow. That would be like the exhaust to the system. You know, if you have a car and you cork the exhaust, you wouldn't have much energy passing through it. So the system needs that anticyclonic outflow in the upper levels to have the exhaust for it to continue development.
Now, Mr. Benjamin, thank you for that. But this reminds me of when I used to work at a volcano observatory, and I'm talking to scientists, and they have this jargon that they use it normal, because they go to school for that and they're using it amongst each other. But what force is that? Because I know it can't be Coriolis, but you just explain that for me, please.
The Coriolis force really is I want to use the word imaginary force that makes the wind turn to the right in the northern hemisphere. It is because of the Earth as it rotates around its axis, that if you were to throw a ball in some distance, that by the time the ball, if you throw the ball straight, by the time the ball reaches the point where it's supposed to be at, the Earth's spin would already take that point to the left of it. So in appearances, it would look as if the ball has veered to the right. And that is what we call the Coriolis Force, in putting it in a very simple way.
And I'm very glad that I'm able to be confident within myself to ask you to break down these things, and I thank you for that definition. And one of the things I appreciate in a conversation like this is the specificity that can be applied to different things. Now, you spoke about depression, you spoke about a hurricane. What is a tropical wave?
Oh, the tropical wave, really, those are some of the genesis of they would cause most of our hurricanes or cyclones in the northern hemisphere. So a tropical wave at a glance, batches of energy or general spin in the atmosphere that would cause the flow to shape as if it was a wave. If you look at it in the meridional sense, that is from north to south, you would see the tropical wave shape as a wave in the sea. The shape of the wind flow would shape as that. It really develops across Africa, just north of the African continent, just north of the equator. And because there's a high pressure cell around somewhere around the Saharan desert with hot, warm air, and this sometimes when it goes back on the western side would carry that warm air into Europe and could be one of the factors for heat waves in Europe. But this air, as it comes equatorward side, it meets up with the cooler air from over the sub-Saharan areas of the African continent, and these are more lush areas with more vegetation. So as the two air masses come together, it causes a wind flow, a jet, you would call it, a tropical easterly jet or the African easterly jet, and it would push towards the west, out towards the Atlantic Ocean. Now these pulses and this energy pulses coming from the meeting of those two air masses would cause the perturbation, so to speak, in the atmosphere and cause the atmosphere to begin to make or form as if it is waves. And as it comes across over the Atlantic Ocean, it picks up more and more moisture, and therefore we can find disturbances developing along the tropical wave.
All right, and thank you. And I really am enjoying this conversation. And this actually reminds me, the way you describe the tropical wave, I remember someone in a spoken word piece was talking about hurricanes following the path of slave ships. But we continue the conversation. When we return, we are speaking about tropical cyclones and much more with meteorologist Gary Benjamin. Stay with us. We return with more. Welcome back. We are speaking with meteorologist Gary Benjamin, and I like the fact that you set the table. You gave us context, Mr. Benjamin, and I want to bring it specifically to Trinidad and Tobago in terms of what are some of the weather conditions that we are expecting right now. You said yes, we're in the hurricane season. What does that mean? And this is even before we started to talk about things like climate change, global warming. But what are some of those things that we're looking for at this point in time with regard to the weather?
Well, we are expecting right now the ITCZ is where it's supposed to be, and that is right around our latitudes. And when the tropical waves that I spoke about comes across, they would cause perturbations and modulations in the ITCZ that would bring it even more northward. So we're looking at the ITCZ weather. We're looking at tropical cyclones, as I explained before. And we're also looking at localized type of weather, because when we have a bit of sunshine with the amount of moisture around, we would have those localized thunderstorms occurring. And even one thunderstorm could be very devastating if it where if you're under it, so that we're looking for the localized weather, we're looking for tropical depressions that will develop into storms and eventually hurricanes. We're looking for the ITCZ, and of course the tropical waves. We have to look at the tropical waves very closely because right now, as we go further into the season, the heating difference over the Sahara, and as I said, the lush areas south of the Sahara, the difference in temperatures of those air masses is even greater. So we're expecting even more tropical waves to be pushed out from the African continent. So we're looking at those things and we keep looking at them very closely all the time so that you as the population should be on the lookout for our information because we are monitoring everything, every single thing that happens in the North Atlantic. We are looking at it, and whenever it poses a threat to Trinidad and Tobago, we would soon let you know.
And I want to talk about that sharing of information just after we go back to something that you would have spoken about in the first half and you just touched on again, in terms of that differential in temperature leading to phenomena. So you just spoke about, okay, well, yes, if there's rain falling and then there's a little bit of sunny conditions, that can lead to thunderstorms. Take me through the steps of that. No, you had to read and spell for me, Mr. Benjamin, but what's the process?
I will try to be as simple as possible. We have warm, moist oceans, and that is one of the things synoptic type, large-scale type developments such as cyclones and tropical waves need. We also have moist air. We have the land. Now, the moist air, because of the mass of the molecules in moist air is lighter than the rest of the constituents of an air parcel, it would tend to be more buoyant and easily able to rise. So that if the ground is wet, like we have normally in the rainy season, we have a wet ground, and we have sunshine, we would tend to have that type of evaporation and vertical convection taking place. As soon as that vertical convection begin to take place, when it reaches a particular level or the lifting condensation level, it would begin to condense into clouds. And as the clouds begin to form, more and more clouds begin to form. If it has that connectivity between the lower levels and the mid levels and the proper moisture, it continues to develop. And with more and more development taking place, it shoots up and it keeps building because it has the moisture, it has the lift, and as it is lifting, it is cooling somewhat, and it is condensing and forming clouds. Also, if above it there is no suppressing feature, it would continue to build because there are features in the upper level that could suppress it or could be warming quickly and suppress the condensation, and the clouds would begin to spread out. When there is not that type of suppression, or the force from below is enough to push through, we find these thunderstorms developing, and they go from the surface into the tropopause, which is a very tall cloud, and that is the thunderstorm that would produce lightning and thunder. Of course, thunder is the sound that lightning makes. And a tropical cyclone is when I spoke about the beginning of the cyclone with pre-existing disturbance, that is a number of thunderstorms not organized coming together and building. As they build, they have to suck air from below, from the surface, and push it up into the atmosphere. And therefore, it lowers the pressure because it is removing air from the surface. And more air rushes in to take its place, and it continues to build, and then it begins to lower the pressure. And then you would see, if it continues to organize even more, you would see the isobaric lines becoming more and more organized, and you would get a central low pressure area encircled, and that is when you begin to have the depression forming. So the thunderstorms, the cyclones, is really made up of a number of organized thunderstorms.
And thank you very much for that. You carry me back to school with that, and I appreciate it. It's the longest while. I mean, I didn't use the term, but it's been a while since I've thought about the term dust motes and these sorts of things. But you spoke a little bit earlier about monitoring. I want you to carry me through that process of monitoring. Okay, well, these are some of the things that you look for. And while monitoring, yes, okay, well, we see this now, so we're going to share the information so that the layperson can become a little more aware of saying, okay, well, these are some of the things that we can look for. We may need to prepare one way or the other. What is the system like for monitoring? And we can even go into the color-coded warning system. Thanks.
Okay. Well, we have satellites which would show us a broad area of the North Atlantic. Our area is called Region 4. It's from Western Europe and Western Africa, all the way to most of North America, Central America, and the northern part of South America. Now, in the world of meteorology, there's a lot of cooperation. For instance, in Miami, Hurricane Center is tasked with looking out for the development of cyclones. And every meteorologist in the region is looking for it. And that's the way we monitor it. We monitor it by looking at the satellite pictures. We also look at the data collected around the world, and we do what is called, predictions by developing primitive equations that would predict the weather into the future. And we look at that also to see how these, now it is pushing it, the models, how the models are saying how it will develop over the next few days. Now, the meteorologists, the models are a tool. The satellite pictures are a tool. It comes like if you're a carpenter and you have the best hammer, you'll be able to build a better house, so to speak. But if you're not a carpenter, you can have the best tools, and the house may not come out all that well. So it depends also on the skills of the meteorologist. And as I said, Miami, all of us have the responsibility of looking at the weather in these areas. We look to see if there's any disturbance, any congestion of cumulonimbus clouds developing. We do the models and run them to see how they will develop over a couple of days. We also have radars around the whole Caribbean. Trinidad also has a radar. So when that is working, we will be able to look at the more closer developments taking place within about 400 kilometers of our area. But we have to be looking at the satellite pictures. One of the major things about a meteorologist, they also have to be looking outside, because you might have a model that is saying a certain thing that this will develop in a particular way. But you have to relate that with what is actually happening, because not all models would predict the same phenomena in the same way around the same season. So the experience with the model and monitoring it would teach you that this model or the other model is not granular enough to predict certain features, but we could take certain other features like the amount of moisture it might say in the atmosphere, how it develops into a cyclone if it has to do. It may not predict that as well. Some models may predict the path of a cyclone, a prospective cyclone. Some models may not predict it well.
Change over time, so that is one of the things we need to look at. But we want to thank you very much for the work that you're putting in, Mr. Gary Benjamin, meteorologist, and the work that you continue to do, as well as the TNT Met Service. And on behalf of the entire TTT newscast, I'm Dike. So this has been In Depth. Thank you so much for tuning in.